units because of the short lines. It's rather the voltage drop is quite low, and it's mostly loading issues. For loading, unfortunately, the nice things like wide area control reactive power doesn't work. Sometimes they even counteract to that. So here, solutions are, of course, always network reinforcements, but also possibilities like including a battery for peak shaving or doing capping on the devices. Recommendations from our side is we do recommend that on the power transformer, especially the high powers, higher voltage levels, that automatic voltage control should be implemented. I have heard that in the meantime this has happened in many grids, so very good steps. For the lower voltage levels like 33 to 11, it's very beneficial, but it's not strictly required. For under normal voltage issues, we do see the wide area control being a very good solution, and in general, also it's should be a good approach to require basically voltage control. We have seen that it can help in many grid situations where there are voltage problems to activate reactive firepower. Especially, I'm talking about volt VAR control that should be required. Luckily, many inverters today are actually able to do that. Further, active power controllability for PV units, especially for large PV units, should be required, should be recommended, so they can be actually controlled remotely. For smaller systems, a good solution might be to have this capping as a solution. Or other solutions are then also peak shaving, and with like new technology, digitization, and so on. Of course, it's also on smart meters. It's also possible also to control smaller units now with remotely. For batteries, we will be talking about tomorrow again, I guess. We'll hear a bit more about batteries today and tomorrow. But of course, not only peak shaving is possible, they can also add much more other values. Finally, on the legal and regulatory framework, our recommendations is remote control of PV units that gives some headache, let's say. So when, who, and how to use it, that needs to be clear. I did understand that you are not so happy with this view with the regulatory framework, so that's definitely something which needs to be clarified. Voltage control I mentioned already, should be possible. Active power curtailment, there needs to be the question, okay, who is paying basically for the lost energy? And in general, it's important to look or to update constantly the grid codes to have this up to date. This is a constant process, so on the learnings and developments, on the penetration levels, to have it then developed. So grid codes is a very important, very important topic. So capping 70 or 75% should then be or could be in the grid code, but that's for sure some legal complications on that. So not everybody is very happy about this approach because there's energy lost. We do see, and that's also something we'll talk about tomorrow, that PV batteries do require incentives. They're still very expensive, although they are giving a lot of benefits. They're very expensive. And already mentioned the grid code is very important, and they also need to be coordinated with the transmission system. So do not look only on the distribution system, also look at the transmission system. So, for example, how the PV units are actually then reacting on frequency response. So if the frequency goes up, they should then also reduce basically the power, at least from a certain level when we are operating in an unnormal state. That's all from my side for now. You can download the presentation here on this link from the THASRA website, and I'm very happy to start a discussion with you and answer any questions. Thank you very much.